Welcome to problem 1. Two natural numbers, a, b, and ba, and with the line on top of a, b, and ba means that it's representing a two-digit number. They're not being multiplied together. Okay, so two natural numbers, a, b, and ba, each divided by 7 has a remainder of 1. If a is greater than b, find ab multiplied by ba. If we're looking at these two numbers in this form that they're in right now, we don't really have much sense of their actual value. So in order to do that, we can turn, for example, this first number, AB, into 10A plus B. This way we can see their actual value. So 10A plus B, we know that when divided by 7, we have a remainder of 1. We also know that 10b plus a, right now we're representing the value of the second number divided by 7 has a remainder of 1 as well. And if you think about it, this is basically using the knowledge of expanded value, right? You probably learned place value before or is learning it, and this is all it's about. It's expanded form. Now, as you can see, I've put a bracket around here to show that these two pieces of information are a group. So let's see what we can get from here. As you can see, they're both being divided by 7, meaning that they have a equivalent divisor. And when we have an equivalent divisor, we can actually subtract this equation, not really equation, but we'll call it that, in this equation. So we can subtract 2 from 1. If you want to, you could do 1 from 2, but I'm going to do 2 from 1. So after doing that, our dividends subtract. So this is combining like terms. If you don't know what that is, it's basically, well, if you have 10, think of A as an object. If you have 10 A's and then you take away an A, you have 9 A's left. And if you have, this is going to go into negative numbers, but if you have 1 B and then you take away 10 B's, you owe that person 9 more B's, so minus 9B. So this new number here, divided by 7, should have a remainder of the previous 2 subtracted. So 1 minus 1 is 0. And we get this from the first property that we learned, which is the remainder of sum is equal to the sum of the remainder. We subtracted, the difference of remainder is equal to the remainder of the difference. We subtracted the remainders and the dividends. So here we can simplify even more. We can factor out a 9 from both 9a and 9b. Take that out, and we have 9 times the difference of a and b. That divided by 7 has a remainder of 0. Well, if 9 times a minus b is a multiple of 7, then a minus b itself should, divided by 7, should have a remainder of 0 as well. Now going back, A and B don't really have that many different possibilities because there are only, of course, 10 digits, 0 through 9, and A and B are each digits, so they're all one-digit numbers. So A minus B, there's only 7 different possibilities for A and B. So A can equal 7 and B can equal 0. Remember, A is greater than B. Or A is equal to 8, B is equal to 1, or A is equal to 9, and B is equal to 2. So of course, right off the bat, we know that B equals 0, that's not possible, right? Or else this wouldn't be a two-digit number. You can't have 0 in the greatest place value of any number. So this gets crossed out. Now pause the video to see and to check which one of these remaining possibilities will work. So you should have 8 and 1 crossed out by now, right? Because that doesn't fit the standards, and all you have to do is substitute A and B and see if they really work, and they don't work. So if A equals 9 and B equals 2, you want to find them multiplied by each other. So 29 times 92. 29 times 92, do the math, and we get 2,668. Our final answer, the product of AB and BA, is 2,668. The key point of this problem is really, well, the key point of this problem is to really just use, what we learned from the lesson. The first step, I think, was a lot of people that may get trapped is in the first step, which is converting AB and BA into their expanded forms. And after that, you need to really pick up, they have the same remainder and they have the same two variables included. Do that, and then the problem just goes out for you. So thank you for watching through Inquisitive Kids, and see you in problem 2.